We'll pause here. Secondly, to help Linda and others who volunteered to be Etherpads, there's an Etherpad. Linda, if you can see where the...
So if you subscribe to that, we'll help.
If you subscribe to that, then it's easy. Yeah.
Everybody can help that.
Then please, if something isn't added, if you read something from your talk that doesn't work, we found that during the interims, Etherpad works very well.
That's fine. Other people can help you fix it.
Do you want to just send it to list? Okay. Linda, Jeff will post it to the list. Okay, we have, I'm going to give the document status for I2RS. Something I've begun to do in my document status is to acknowledge our shepherds as things go to the ISG. If you would like to be a shepherd, please just let me know. But our architecture draft finally went to the ISG, and Mak Chen shepherded that. The I2RS problem statement went to the ISG, and Quinn Wu shepherded that. We have several adopted working group drafts. We had previously adopted IETF I2RS RIB info draft and the use case draft. We have now added the I2RS pub sub requirements and the traceability draft. The protocol drafts are part of our next 4 months focus. We will have the requirements and these drafts going to working group last call. There is an adoption in process for draft CLEM I2RS Yang L3 topology. That should be the generic topology. I may have the wrong thing. And a draft Wang I2RS RIB data model. That's the Yang data model for the RIBs. Please, if you haven't reviewed and made your comments on the list, do so. Today we will be hearing about topology drafts, and we will be holding a adoption call from the 2nd of April through the 16th. We will also be starting a protocol requirements design team, and that's just to finish off the last of the draft HAS I2RS NetMod NetConf requirements. If you're interested, it's about 3 to 4 conference calls during 4/2 to 4/17, and then a working group last call. If you're interested, please contact me. We're also starting a filter-based RIB design team. I'll describe more about that later, but we have 2 info drafts we're looking at. We will be pushing through some more interims, again, at this point on Thursdays, 10 to 11:30, with different topics that are listed here. I will continue to send out information on these interims. Now, what someone mentioned to me during this week, that it would not only be good to have the interims and the slides and the minutes, but that a short synopsis for people who didn't go to the meeting would also be useful. So I will try to send out, a paragraph of what happened at the meeting and what you should look at. Our working group last calls will probably include working group adoption calls will occur through next time. So that's our status. We've managed to stay on target with our status, and we will start with our protocol.
Good morning, I'm Jeff Haas. So this set of slides covers basically the same thing that was presented to the NetConf working group. Next slide, please. So the draft I threw together is basically my attempt at summarizing what the working group consensus on protocol issues appears to be. As I mentioned to the NetConf group, this is not a formal draft that has been adopted by this working group, and actually that was a somewhat contentious point for some of the people in the NetConf working group. This is effectively a to-do list showing the things that we have noted as issues, and at some point we need to actually generate formal requirements documents from this. As an example, the pub sub document that has occurred in I2RS is something that covered a set of the requirements that were formally published in here. And thank you to Eric and Alex and other people to actually get that out and have a document of very high quality covering those requirements. Long-term goal is really to make sure that we have individual documents covering each of these points. Next slide, please. So, as I mentioned, the pub sub document has been published and has been adopted by the working group. I'm going to encourage everybody in this room to please pay attention to this. We actually have two audiences that the pub sub requirements are addressed to. The first one being our requirements in terms of these are things that I2RS needs for being able to do subscriptions, receive notification screens, and potentially enable speedy delivery of subscription state. For example, if you're trying to subscribe to a change of a given route inside of the routing table, you want that to happen fast. It may not be able to happen over a traditional NetConf notification stream, even if it's off to a separate server. This may push us into alternate formats, and this set of topics has been discussed in the requirements document. The other audience that we have is the broader IETF. We are basically leading the way for some of the requirements on this stuff, and as people are starting to become more aware of NetConf and Yang and the things that it can do and cannot do, they're starting to have to think through these things themselves. Next slide. Ephemeral state is still our major sticking point. We've gone through a couple of IETF sessions where we've actually demonstrated what the Venn diagrams of the different state could look like in the system. These were meant to be examples of ways we could model our stuff, and until very recently, we had nothing to show that said, here's actually what we want to do. And conveniently, this has changed in the last couple of months. We now have actual IETF drafts in I2RS that have data models associated with them. We're no longer talking about something that's completely theoretical. What this means is we can go back to those Venn diagrams and show what, and reference back to things like the New York City NetMod interim, where we actually discuss some of the protocol implications of those models and actually use this to help us refine what our requirements are for being able to do ephemeral state. Another issue is the secondary identity. As we know, the architecture document is using this primarily as a form of traceability information. For example, in cases where middle boxes or proxies are involved. We don't know how that's going to show up in the protocol. We're not sure how that's actually going to show up in the Yang. The Yang language does actually have the idea of metadata associated with it, and that may be a convenient place for us to put it, so we'll have to actually have that discussion. Priority is another thing that is part of the I2RS architecture and is not really a native concept to existing NetConf and Yang. In terms of being able to do tie breaking based on who has priority on some particular bit of state, that needs to be added. Again, how is this carried in the protocol, and how do we actually put it into the Yang itself? Transactions. We have 3 sets of transaction behaviors that we're expecting. This is mostly, I think, a matter of mapping this into the NetConf and the RESTconf requirements. It's possible that a specific behavior set may actually require one of the specific protocols or potentially extensions of those protocols. As an example, perform all or none is something that can be accomplished both in NetConf and RESTconf. Perform all until error is something that can be easily accomplished in both of them. Perform all storing errors is sort of a ambiguous point at this point. So clarifying that mapability, make sure it's written down somewhere is going to be a task. So in terms of future steps, the thing we really needed the most help from in the NetConf group was figuring out how we could actually move forward with ephemeral state. The feedback we have gotten from some of the members is we really need to formalize what we're asking for so that it's clear to them. I will also be working with some people from Juniper Networks. Juniper does have an implementation of an ephemeral database that actually already works with our system, and we'll be trying to write this up as an example of how we actually do things to potentially speed this process up. Whether that ends up being what I2RS adapts is obviously an open question, but using that as a basis of something that has been implemented may actually speed this a little bit. Questions?
So, questions? This is what we're looking for, volunteers for a design team to help finalize the requirements, the protocol requirements. If you're interested, please get a hold of me or send a note to Jeff or I, and we'll put you on the team. It's a pretty fast, please give us your opinion and we'll make sure these requirements get completed. We're looking for people who are available in the next 2 to 3 weeks. Thank you.
Hello everyone. So this is a update on the RIB, that's the Routing Information Based Info Model. So this has been a working group document for some time. We've actually worked together with the folks who are doing the data modeling, both in the NetMart group as well as in the I2RS group. So we have updated the draft mainly, I think, based on the learnings that we have had while doing the data modeling. So a lot of it has been to improve readability as well as some small semantic changes. Next slide, please. So what are the major changes that we had? One was we changed the terminology a little bit. Previously we had the next hop term used for a structure that is fairly low down in the hierarchy to explain what the next hop is. But the feedback that we got is that a route is basically, it has to have next hop right at the top. After you do the match, you need to express that entity as a next hop. So previously we had it as a next hop list, and we have changed that, renamed that to be a next hop. Also, we had a way of expressing the different reasons for which the next hop is used. For example, load balancing, or protection, or replication, in a way that was complicated for people to understand. So we kind of split out and explicitly called out why we are grouping a set of next hops together, and we have used a recursive structure within that to express all different possible ways in which you can use the next hops. That is, you can have a combination of load balancing and protection using primary backup for each of those components of load balancing. So this version of the draft really clarifies and hopefully simplifies to a great extent the organization of the data within the information model. So we've explicitly called out whether a group does load balancing and it has weights for load balancing just in that particular subtree. Similarly for protection and replication. The next change that we have done is that in the previous version of the draft, we used to have primary backup, but it was just a single level. So you could not do things like a backup to a backup and so on. So in this version, we have actually generalized that and made sure that you do the primary backup based on a certain protection level that we have that you associate with that next hop. So previously, your protection preference could only be 1 or 2, which is essentially primary or backup. But now we have 1, 2, 3, or 4, and depending on your underlying fib, if it accepts just a primary and backup, then you basically download the 2 highest level preference next hops in order to do protection backup, primary backup protection. The other major change is, of course, the grammar. We have received a lot of feedback on the grammar. Now, there is one thing that I wanted to clarify here, which are explicitly stated in the draft. So we have expressed the information model in primarily English, and we have used the RBNF to clarify in greater detail what we've expressed in English. But the authoritative text still remains the English language description, and RBNF is just to simplify reading of the draft. Next slide, please. So those are the major changes. So most of them are to improve readability, a couple of small semantic changes, but there are a few topics still under discussion, and folks have already talked to us, and we would like to see more feedback on the list as well. The first topic that we are considering is to add in next hop in another routing instance. So you can have 2 or 3 routing instances where you specify a route as part of one routing instance, but the next hop really comes from another routing instance. The next is tunnel types. Currently we have several tunnel types like GRE and PLS and all of those listed in the draft. But the one thing that we have not done is IPsec, so this seems to be an important case for a few people. So this is something that we are considering adding in the next, hopefully in the next version of the draft by the next IETF. So this is the major things under discussion. If there's any other thing, I would like to see feedback from people and bring it up to the list, and we'll take care of it. That's all I have.
Ganesh. So the question had been asked on the list, how does this actually correlate to the netmod routing config module? I understand that work will be happening to provide that comparison sometime shortly.
So this is an information model, and that is the data model.
Sorry, I've gone too far ahead.
Right. I think this is a question for the next draft.
Yep.
So we'll wait for that.
So, thank you, Shiganis and several of the design team members did a great job at revising and working on this. Hari, would you like to do this next one? Thank you, Shiganis. Oh, question. Go ahead, Anoop.
Yeah, question. Anoop Ganwani from Dell. What's the use case for having the next hop in a different routing instance?
We can probably discuss this offline, but at a high level, you want to have, let's say, you're arranging your routing instances in a way that a different routing instance is managed by some person who's doing the routing for the core, and here it's like an access. One of the routing instances in which you're receiving traffic for the access. So you want to say that in the core routing instances where you really get your next hop from.
Okay, I think I'll probably catch you offline as well.
Okay, thanks.
Anoop, let us, we can give additional input if there's more questions on the use case.
This is Linda Dunbar. I see you adding the IPsec tunnel. Would you add other tunnels as well? Like if the next hop you have to go through VXLAN or
VXLAN's already in there.
Is it there? Oh,
Yeah.
I'm sorry. I apologize.
Okay. Thank you. Hari?
Hi, Hari from Packet Design, presenting on behalf of the design team, all the authors.
Can you hear him?
Please.
Just a minute.
Close to the microphone.
Get real close. Yeah.
Hi, I'm Hari from Packet Design, presenting the data model on behalf of the design team. Next slide, please. So this kind of goes with the information model. It's being used to write. We use the data model to read and write rib info. It kind of goes on directly. It kind of aligns directly with the rib info model draft 06 version of Strigan HT. Next slide, please.
Okay.
This is a high-level module. As we all know, we have a top-level routing instance, and there are some capabilities that could be exchanged. We got some suggestions on the mailing list to have capabilities as features rather than just booleans. We'll take that account into our next version. A routing instance will have the rib list, and ribs will have routes. And we have a couple of notifications as defined by the information model, which is like the route change notification and the next hop resolution change notifications. So these again, same thing but in more detail. You should be familiar with the diagram. A routing instance could have a list of interfaces and a list of ribs and a list of, and each rib will have a list of routes. Rib capabilities again. So this is not all I2RS agents will have, or the rib managers will have all the capabilities that I2RS client wants. So this is basically to tell the I2RS clients like what each I2RS agent is capable of. So this will be as this will be exchanged as part of the initial hello or something like that. We are still working on it. But right now, as I said, it's all Boolean, but we'll make it like feature based. Next slide, please. Route structure. This is kind of directly correlates to what is there in the info model. You have a route can have some route attributes, or you can have a vendor specific route attributes. There is a match, and match results to the next hop. Match could be of a couple of types, all these types. Next. So next hop structure. So it's like a little complex structure. So as described in the information model, next stop could be a single next stop, or it could be a recursive next stop with a couple of options here, which can have a next stop chain. Next stop chain in turn could have a couple of other things like egress interface, logical tunnels. It could have, you can also push some encapsulation packets on top of the existing things. Okay, so recursion again. So from how the information model, as you all know, it's kind of described in RBNF. It has a recursion, so we try to kind of have this recursion as like a flat using the using identity refs. We kind of described them as a structure so that you can have any level of recursions that could be modeled with this model. Next slide, please. Notifications again. So as described in the information model, we have two notifications right now. One is the next stop resolution change, the other one is the route change notification. So we try to use grouping as much as possible so that we don't need to redefine things in the notifications. So as much as it's described in the original Yang model, that will be reused in the notifications. Next steps, what group polling has started, solicit more comments.
I'm sorry, I have another question for this. The recursion, when do you use the next hop recursion, this part? Like you send to next hop, you only exit and then packet come back?
No, because it's our route resolution, right? So next stop could point to an IP address. That IP address in turn is reachable through another route, so which has to be recursively, for example, a BGP route, which has to be internally resolved through another IGP.
Oh, okay, so it's almost to another routing table.
Right. It could be on the same routing table, or it could be on a different routing table. We have various scenarios where you could have recurse your next stop into different ways.
Okay, so it's not about looping back packet.
It's
Okay.
not about loop. It's about how you resolve your next stop. It could be a direct next stop, or it could be kind of resolved through another route lookup.
Any other questions for Hari? Okay, thank you.
So now I'll ask the question I incorrectly asked before. We've been asked about the correlation to the router config module. That's something you're intending to do?
Yes. So we are kind of, we want to align with the routing config module at some point. Once the ephemeral state is kind of nailed down, we'll try to see how we can augment this into the routing config module.
A lot of volunteered at breakfast to try to help us, so I think we need to give thanks to our Yang doctors.
Sure. So at the end, we don't want two modules. We want like one module. But once the ephemeral state is kind of finalized, we should be able to augment this into the routing config.
If there's no more questions, we'll go through the traceability.
Thank you.
If you're looking at the agenda, we took things a little out of order. Is Joe here? Okay, so I'll summarize things for Joe. He sent it in and wasn't sure he was going to be here. So this draft was adopted as a working group draft, and he's had, this is a update report. All open issues he feels that were raised on the list and at various interims have been addressed, and the authors feel this is ready for working group last call. Additional reviews are always welcome. In fact, we hope to get some pre-reviews from our NetConf folks, as this will be one of the requirements. The changes since 91 is additional timestamps, syslogs, added a Boolean field to indicate if operational data is present. This operational data state did not have the type of suggestions that the open config had, so this is pre that. mentioned trace logging that can require additional resources, added trace log export that didn't block I2RS operations, and recommended timestamps. If you have any questions, please send it to the list and or talk to the authors, Joe, Gonzalo, and Carlos. Next will be PubSub. Eric? This will not be online. I will post it immediately after the working group.
Hi. On behalf of Alex and Alberto and I, I'm going to give an update to the PubSub. You might see 02 on there. I posted a new version last night incorporating some of the comments that I got from Benoit and others in the interim. Next slide. Now, since Hawaii, we did an adoption of the version of the VoIP that went to the list. There's a number of changes we've done in the subsequent revisions to the adopted. The three new areas that are completely new areas of the requirements document are subscription QoS requirements, filtering, and some assurance and monitoring. Everything else above and beyond that has been tweaks to the original text. Next slide. Now, changes that were posted last night are a lot driven by comments, as I mentioned, that I got from Benoit and others. Things that are in there are a number of things that are, fairly minor. Identifying that the QoS is really subscription QoS. Benoit told me to stop yelling because I had must and should in uppercase, so moving those to lowercase. Making some mobile and other minor changes is really where we're at. So just for those of you who are going to be taking a look at the 02, these are some of the major changes, or the minor changes. Now I'm going to talk about some of the big changes since the working group adoption call. Next slide. One of the big things that happened since working group adoption, and Jeff mentioned this before, is that we're looking at requirements that are well above and beyond I2RS. There are hundreds of Yang models that are out there, and the working group chairs and the EDs got together and said it'd be good to have one requirements document for PubSub across many different working groups. And considering there's so many hundreds of Yang models out there, well, we're looking at them. There should not be an expectation that you can do a traceability matrix against every Yang model that's out there to say what's going to be needed for PubSub or not. So while there's a lot of requirements that are driven by I2RS, we have to recognize we're going to try to generalize requirements across a very large moving range of documents. And in the end, there's a set of requirements that are common across them in everything from security to periodic to on change to the dampening period. These are all things that are in the new version of the draft. Next slide. Now, subscription QoS parameters are interesting things because they really get into the differences between very fast updates from routing protocols or very slower updates by monitoring operational data or things that would happen in, let's say, 30-second intervals. Some of the things that are key here is a dampening period, knowing that you're not going to be sending updates so fast that the other side is going to see, root flaps, for example. Some types of things monitoring, you might want to see the root flaps. Some might just want to see what happens after things get stable. Issues like reliability, making sure that there might be some clients that really want to have some transport which guarantees delivery. Presentation, being able to bundle a number of things together so that they're all together in an update versus being sent in discreetly. Deadline, making sure that you're able to send multiple network elements are sending the, let's say, counters at the same exact time period, so they synchronize across the network at the same, and also push latency, making sure that you are able to know exactly how long it was before an object was generated to end the notification. Next slide. Now, filtering is also a very interesting topic that has been added. We have a start of some very simple requirements for having no filter on a subscription, so you're literally getting everything out there, but that can overwhelm some systems. So there's more and more complex type of filters that are out there. The most simple are the kind that you would see out of an XPath, where you could say, give me an update an event if, you have a yellow triangle, or if your route is equal to this subnet. And so it might give you an update there. However, you might not want to get other updates. Other technologies and other standards bodies like OMG's DDS actually can install effectively an SQL query, a running SQL query, so it does multi-object types of lookups. While we're not precluding these more advanced type of filters, and we're actually making sure that these could be added in the future, we do not have full coverage for what would be the syntax of loading and running SQL query into the network. So while we have the requirements covering this, we're making sure that we're not precluding some of the more complex types of filters that might eventually be loaded into the network. Next slide. Now that was for periodic. In terms of on change, when you're notifying things on change, there's requirements that are also simple to complex queries, but there's also the need to understand the difference between filtering events and filtering and maintaining a remote state. And this is a really important one. It's easy to say a route has changed. It's hard to say that a route that you're monitoring and you're filtering went away. So the idea of knowing that you can create a object of property is important. Knowing that you've deleted an object of a certain property, it means you have to know that you are maintaining the state remotely. These are, again, requirements that we think are important, and we're making sure we don't preclude, but having stateful filters for subscriptions is something that we're not precluding, but we don't believe we have all the requirements there too, other than listing out the categorization of the type of requirements. So this is key. I don't see this in the current I2RS requirements. It could come at some future time. Next slide. We've also added some requirements in on assurance. You can read them in the draft. Next slide. So to sum up, there was a desire to see and solicit the comments from you guys, not just from I2RS, but from the other working groups that care about this type of stuff. We intend to participate in the working group last call type of set of drafts that Susan mentioned earlier. We believe that this is ready for last call for review to see where things are at, and we need people to do the kind of review that Benoit did for us. And also we have an offer out there for anybody who's interested, is we do have some running code that's based on the technology draft that Alex and myself and Alberto put together. And if there's anybody interested in PubSub and want to do an interop based on draft CLEM, we'd be very happy to work with you in the interim to just show how the PubSub can operate. So please contact us. Any questions?
Thank you very much. Alexander, it'll be you next. Just give me a moment. So, our agenda this morning started out with the quick status, the protocol, the traceability, and the PubSub. We've gone through the RIB model. Now we're going to go through a whole bunch of new models regarding topology that are based on the generic topology. The draft CLEM I2RS Yang network topo is the thing under working group adoption. It is a generic topology. That generic topology Alexander will go through, and also its development with L3. Then we will have Yifeng, if I believe he's here, talk about the T's working group, just a summary of their TE topology, and then we'll go through L1 topology, L2 topology, and some initial attempts at service topology. Those are models that we're filling out that are protocol independent. Protocol specific I2RS models will be done within the specific working group. For example, if you're doing a BGP I2RS model, it will augment the BGP model that's being developed in IDR. And with that, I will go to I'd like just one more moment, Alexander. I would like to thank the members of the RIB design team who worked on quickly coming up with the Yang model and also keeping the info model updated to match. I'd also like to thank the topology design team members. With the folks, I'd like to thank them very much for all their hard work. In a matter of 2 to 3 months, they came up with a whole suite of drafts. With that, we'll go on with Alexander.
Thank you. So, yeah, good morning. So basically this presentation covers 2 topology models, although I'll focus on the generic topology model one, which is basically the one under adoption, and then the layer 3 basically is presented a little bit on the end. So next please. So the purpose, just kind of like as a recap, I think as most people here will be aware, so the purpose of this was to provide Yang models, data models that can represent topology, which basically means that they need to be able to represent both the horizontal relationships between nodes and links and so forth, as well as also the vertical layering relationships between overlay, underlay topologies and so forth. The goal of the general topology model was to extract commonalities between different topology types and basically focus just on that part, which is truly common across all of those topologies, and then basically provide the hooks, if you will, that allow for easy extension and derivation of additional topology types. In terms of basically the applications that drove this, there's a topology management section in the I2RS architecture document that calls for topology management. Is basically the basis for that, and really actually there's a variety of applications above beyond that, basically data nodes that need to capture and reconcile the understanding of the network topology and propagate it among the network, as well as also network controllers that need to represent network topology and so forth. So the current draft is in 0.4. Changes since the 0.2 version, which is the one that we had until relatively recently, so we had two drafts in fairly quick succession, was a couple of minor model updates. We'll get to this in a moment. Most importantly, basically, there's a split now between the overall topology to the network, which basically includes the node inventory, that's the most basics, and the network topology itself, which basically adds the links and termination points. And then there are a couple of editorial updates, mostly minor tweaks. There's also two new sections. One section that describes how to extend and use the model, as well as also a section following some discussions in the hallways and also on the mailer concerning how to represent the same devices, basically in multiple topologies. Next, please. So the overall architecture of the topology model is depicted here. The blocks in blue are covered within the general topology draft, and so we basically have the abstract network model that is basically at the top of this, and the topology model, which represents the topology with the links and termination points. Then from that, the more specific topology models are derived. So basically, L1, L2, L3, service topology model, actually all of them have also companion drafts, as well as also inventory model, actually same thing here. So really basically have a system of models, so to speak. Next, please. So yeah, in terms of the horizontal vertical layering, as mentioned, basically it was one of the goals to be able to capture those types of relationships. On one hand, obviously basically the relationship between nodes and links and so forth, but also the ability to capture what the overlay or underlay is, what topology sits on top of which other, which nodes basically map onto each other and so forth, along with the necessary integrity constraints. Next, please. In terms of the, basically just a recap of the basic concepts which are present in the data model. So basically, you have the network topology consisting of nodes and links. And nodes in turn basically contain termination points, and termination points and links are connected to the termination points to the nodes. Next, please. So this diagram here basically depicts the Yang tree of the structure. Again, the two modules, basically the split occurring basically between the stuff in black and the stuff in blue, and you see basically the essentially the network network having a type. This is basically where you would extend what if you add this, or if you basically derive a model of a specific type. This is basically where you would basically augment into that. Then you have basically the information on what topologies and so forth are below, and then basically you have essentially the list with the nodes and the links and the termination points. So next, please. So among the things to also mention, the model does allow to represent also different corner cases, if you will. So basically you can have multiple overlays, so it's no problem. You can basically have, for instance, multiple topologies refer to the same underlie topology, if you will. So this is an example here. Next, please. Likewise, you can have also multiple underlays, and we see this here, that basically, in this case, this actually also addresses the question, for example, what if you have a physical network with physical devices, how we can represent that it is part of several other topologies on top of this. This would be basically an example here. Notice actually this is a very basic topology. It's basically doesn't even contain the link information here. And essentially you have now multiple topology which themselves form a hierarchy, but they all basically map onto the same topology here as an underlay topology. Next. So that was the general model. Then basically regarding the L3 model, actually the L3 model needs to be updated. So we'll do that actually shortly. Actually after here there are some of the general model updates which basically need to be tracked into here. But the basic idea is that you essentially refine, basically augment into the node and link information, the specific properties that are related with layer 3. Next, please. And then basically this essentially recurses then for IS, OSPF, and so forth. So you can have multiple tiers of the inheritance hierarchy, so to speak. Next. This here is the Yang tree of the layer 3 Unicast IGP topology augmentation. You see basically the specific node attributes, the specific link attributes which are being augmented basically into the respective places in the generic model. And as mentioned, the draft needs to be actually updated shortly to reflect some of the generic model updates. Actually, they are included. They are actually reflected on the slides, but they're not reflected in the draft yet. Next, please. Okay, so actually this is the last slide. So again, the goal is to focus on the generic topology is to focus on what is truly common and what is being needed by all topologies. There are also certain other features which may be generic but not common to, but not needed by every topology. The idea is basically that also those things would basically be represented in separate models, so to not basically not overburden this one. So the general topology model is a very basic foundational model in that sense. There are a couple of other discussion items. I think read-only versus read-write. I think this one is concluded. Should mention actually there have been two other issues that have been under discussion that have come up that we are basically in closing concerning the data types for the node and for the link for the link identifiers. Those are currently represented through URIs. There's basically the question should be URIs or should integer be allowed? So basically we need typecast information for this. is one aspect. The other aspect concerns the issue of the link identifiers. Again, same question basically to whether to have a separate link identifier or whether to have an identifier that is basically similar to a flow key, basically where you basically combine the tuple of your source and destination identifiers to identify links. But those seem to be smaller issues that we should be able to close in shortly. Okay, and that's basically concludes this presentation. Question?
Okay.
I love this draft. This is really, really good work, especially the way you draw the different layer. That's really, really good. Really impressed by that. Just one minor question. If you go back to there's a picture of the service. You have L2, L3, and then service. There's one picture. I just like L2 VPN, L3 VPN, and then you have a service. Go one slide before that. So I was thinking L2 VPN, L3 VPN is a service, right? Then you have another service topology. So besides L2 VPN, L3 VPN, what else are you considering in the service topology? Just to clarify that.
Well, there's a separate service. Actually, there's a separate service topology draft, and basically the idea is that whenever you have a new type of topology, then you basically augment the generic, basically the general model. And this basically, represents the additional properties that you need to have there. Now, if you do have different types of services, you can basically recurse the pattern. So clearly, just like we have in L3, we have basically pattern recurses to go to ISIS and so forth. You could do the same thing for services, presumably as well. So the idea is basically if you have specific type of services, you basically attach or you augment, I should say, basically the service-specific properties that are associated with the nodes and the links and so forth basically into that portion of the model. Then basically concerning representing the layering relationships, this is basically where you say, okay, I have this service topology, maybe one service having another service as an underlay. This basically, the facilities to do that is provided by the basic model. So basically the capabilities that you can say, that you can basically indicate what is the underlay, what is the overlay.
So hypothetically, I could have a CDN service on top of what you have here, the content delivering service. Is that what you intended for? Just to clarify, the service is like more generic service?
Yes, so
Okay.
yeah, yes.
Thank you.
Mm-hmm.
I believe Jürgen's next.
Jürgen Schwerwälder. Hi, Alex. Can you once again explain why this has been split into two modules? Why is this not just one module?
The reason was to basically, well, the reason was actually because in some under certain circumstances you would actually even need just basically the inventory of the nodes, if you will, that you have inside the network, and was basically seemed that it would be good to therefore basically keep that information separate.
It might be useful to think about the trade-offs. I mean, you introduce a new namespace that causes more clutter at the end when you have instance data. If it's really important to have topologies without links, is great. You could also think about using features or something like that.
It's your turn, Lou.
Okay. I wasn't sure where I was. Thank you. Lou Berger, can you go back to slide, I think it's 3?
This one?
No, back more. That one. Oh, I even got the number right. Cool. So how do you see TE topology fitting into all this? Because I don't think you really mention it at all in your talk, and there's a couple of oblique references in the draft, but I don't see where it fits in.
Yeah, we had this actually formally in an earlier version, but it was taken out, and I think for this one, I saw Shupeng earlier.
Yeah, he's hiding in the back.
Okay, maybe Shupeng wants to. Would you like to comment on this? Because I'm not a TE expert, so I would actually want to defer this discussion.
Yeah, I have to say, what I'm really doing is playing Jeff Haas in T's and doing the inverse of that. And so he asked the question of, from the TE topology, how that model fits into here. And there was one answer, and I want to sort of see if the inverse answer is true.
So,
Would you give a comment, or?
Lou, while he's coming, our initial intent was to augment, the initial discussion was that TE augmented each L1, L2, L3, but we wanted to follow the TE working group, which is why next is Yufang's presentation. Was that the same answer as Jeff?
It's pretty close.
Oh, good.
You were more specific because you said where it fits in.
Mm-hmm.
We in T said we'll let the design teams figure it out, or we'll let the authors figure it out. So we didn't constrain their answer.
Right. So I'm reporting what I think I heard from the design team.
Okay.
Not
Yeah, I
my
mean, if
work.
this is going to be answered in the next speaker, by the next speaker in his talk. We can wait
Yufeng's
till
the
then.
next speaker. Lou, and the rest of the people, this is our next journey of work in these topology areas, is to add TE. So we may not have all the answers yet.
Yeah.
We're just trying to follow the T's working group.
So if you're saying by add TE is to ensure alignment between the different models, great.
That's exactly it.
Cool, thanks. But I'll let you know.
We used to have a picture of that, but this one, so it's not showing the TE. We had a discussion, so the TE will be derived from the base topology on side. So it's separate track. And this is Shifeng Liu from Ericsson.
The cool thing is Shufang's a author on both this draft and the next one, so I have confidence the design teams will work it out.
Yep,
Or
me
the
too.
authors will.
The authors will work it out, yes. Okay, any more questions? Please go
Yes,
ahead.
I have. Yeah, my name is Georgios Karagiannis from Huawei. Alex, thanks for the presentation. The figures were very clear. And I have a question regarding the service model that you have shown there. Are you considering, I mean, in one of the previous slides, are you considering that the service model or the specification of the service model is in the context of I2RS?
Yeah, do you want me to answer that?
Yes.
Yes, it is a protocol-independent service model, and we'll give Michael, hopefully Michael's here, we'll give an initial service models. I would say service models need more discussion and more help, so we welcome anyone who's interested.
But the CDN service model, for example, is also in the context of this work?
The CDN?
Yeah, there were some examples mentioned.
The only example that was worked out by members of the design team was a service model and then subset off of service function forwarding. If you have some other things, we'd love a discussion. It is an area that still needs more work.
Okay, so it is actually, from what I understand, is a service model that is actually very close to the topology model.
These are protocol independent. We are still coming to, as you noticed from, let me get the right draft. As you noticed, some of these models gain information from different other models. We started with something that was concrete, like a service function forwarding. We still have to talk about how all this works inside of a protocol-independent service model, which is what is in IR2S's purview or charter.
Okay, I agree that we have to clarify that. Thank you.
I'm sorry, I didn't hear you.
I agree that we have to clarify that, I think, yes.
Yes, we do need help,
Yes.
please.
Himanshu.
Yes,
Himanshu
Himanshu.
Shah. Yeah, maybe more clarification on Because there is some service model aspects in L2VPN working group that will be working on, and I think there is an L3VPN also, there is a service model. So I don't know how this overlap would work out.
So remember, I2RS models always follow the models that are already existing in the protocol. For example, BGP has its base configuration model and service. Only on top of that can I2RS sit. If there is an model in one of the other working groups, only on top of that can I2RS provide information. So when I was asked to review the service function forwarding model, I made notation where there was interjection with the service function forwarding Yang model, the Peno draft. The OAM draft doesn't seem to overlay. But there's a lot of work there. I think this stuff is real early draft in the service. So it really is worth a lot of critique either to the authors or to the group to see how these service models fit together. It's the area in this whole topology that I still feel we need a lot of input and discussion on.
Okay, so it's work in progress. So
I would say the layer 1, layer 2, and layer 3 have substantial, pretty good discussion in the design team. I would say the service stuff is real, needs more discussion.
Okay, thanks.
I'd like to interject. So I'd like to remind the working group what our charter actually says we get to do. We get to provide the ability to extract information about topology from the network. Injection and creation of topology will not be considered as a work item. One of the things that the models that are being presented here have as interesting considerations is that we are providing some of those fundamentals capable of doing reads, but if I recall some of the model data implementations, they're actually being set as config true in some cases. This is necessary because even though it's not I2RS's job to provide write capability to topology, since we're encouraging people to adopt a common IETF-wide basis for these models, we have to make sure that our model is capable of accommodating that without requiring revisions that are not capable in the Yang language via augmentation. So this means that we have a strong opportunity, and we have to resist that opportunity to expand our scope well beyond what is within the scope of I2RS. So, CDN, for example, we could cover some amount of CDN topology in terms of discovery and reporting, because that's within our charter, but mostly we're expecting this type of work, that when it becomes service-specific or protocol-specific or working group-specific, we're providing the framework which other people can build upon. We're not intending to design everything here, although one bit of advice our area directors have given us is that if it becomes the case that it makes sense to work on a larger set of items in one working group versus another, that's okay. We will obviously be discussing with the various working groups to figure out where that work happens.
Sri Ganesh Kenny from Ericsson. So I just had a quick comment on the way the naming is done and the split up is done. You're currently calling it L3, L2, and L1, right? Whereas I guess L3 really means IP in this case. And at the same time we call it protocol independent topology, but it's really IP is a protocol. So layer 3 is to me it seems like it's an IP connectivity service topology model rather than splitting it as layer 3, layer 2, and layer 1.
That is true, and obviously as you go from the generic to the more specific, it becomes more and more technology specific in terms of the hierarchy. That's correct. That's correct observation.
Okay, so I mean, if you could consider renaming it at some future point, I think it'll make it easier for somebody to follow the real reason why it's called that.
Sorry, what was this?
I was saying if you could consider renaming instead of L3 topology, you could call it as the IP connectivity topology model.
Okay, so note taken. Any other questions?
Is there a way to get that? Okay, Gifang? Could you take the focus for us?
My name is Pawan Biram. I was asked to give a quick summary of the model that's currently being worked on in the T's for representing and manipulating T topologies. I'll be presenting this on behalf of the authors of the draft that's listed in the top left corner. So this is a quick overview slide that kind of summarizes the salient aspects of this model. We were tasked to put together a technology agnostic T topology model back in December, and this draft, the model proposed in this draft attempts to do so. The T topology building blocks proposed in this model are generic and extensible, meaning any technology specific T topology model should be able to take it, augment it to fit its needs. All standard generic T-link attributes should be covered by this model. If there's anything missing, please do let us know. As far as generic node attributes are concerned, we put in a generic connectivity matrix which say an OTN T topology model or a lambda layer T topology model can quickly augment. The model also allows multiple information sources. Model allows each topological element to have multiple information sources, and each information source has a precedence, credibility preference field associated with it to determine precedence when you have multiple information sources for the same topological element. So using this model, you should be able to build a T topology with elements learned from one single source, or build topology with elements learned from multiple sources. So for example, if you have a T topology built using elements learned via OSS, ISIS, and then you inject topological elements from some other T domain via BGP-LS, you'll have these imported elements having information source pointing to BGP-LS and the native elements pointing to ISIS, and so on and so forth. The model also captures the overlay and underlay relationship for nodes and links. So if you have a set of hierarchical T topologies, you can start with a specific topological element in the topmost topology and then work your way down to the supporting elements in the bottommost topology. It also facilitates this notion of T topology as a service where you can have a provider network abstract its topology and provide different abstract views on a per client basis. These abstract topological elements are typically decoupled from the actual network topology, and they belong to the client namespace, and they carry sufficient information for the client path computers to compute paths across this provider domain. When these abstract topological elements make their way into the client topology, they will have some indicator saying that this is an abstract element, so that the client can request changes to this topological element if needed. The model also provides the ability to specify scheduling parameters for the topology as a whole or each individual topological element. The use case there is this would allow the provider network to present different abstract views at different time slots. The building blocks proposed here currently aren't tied to the generic building blocks that Alex just talked about. We initially had it, but then we took a conscious decision not to tie our fate with any other model. But now that GraphClem has evolved sufficiently, it's time that we plug these two building blocks together, and that's what we will be working on in the near future.
Any questions? Thank you very much. The next will be L1.
Good morning, everyone. My name is Xian. I'm working for Huawei. I'm presenting a draft called Young Data Model for Layer 1 Network Topology. So it's part of the effort for the I2RS design, topology design team. And the Young model presented in the draft is to be focused on Layer 1, but it's data plane independent, which means it can be further augmented to include to represent optical transport network, SDH if necessary, and DWDM, etc. So this draft might answer the question we had just now. So this is when I write the draft, I have a question myself. I'm sure most of you do, if you care about optical transport network. So what is the relationship with this draft and all the others already there in terms of topology? So this is the idea I have. You may agree or disagree. So at that time when I read the draft, it's only one generic topology, but now they make it two. Anyway, so related to this draft is the generic topology model as well as the TE model. So I think that one should be augmented from either one of them or somehow aligned. That's my thought. So I will get back to this later when I present the slide. So I show the tree a bit here, but I don't expect it to go to the details because the details are devil and you don't want to see it here. But I want to give people a feeling, what the structure looks like. A topology, and then you have a node list, you attach attribute to a node, and you attach that attributes particular to layer 1 to the link as well. So another question I think most people will have is, when you present a model, how are you going to use it? If you are a user using an IP network, you probably don't care about what's underlying below it. But so I specify that in the draft, and these are some of the use cases I can think of. First one is, if you're a consumer of the transport network, so you probably want to have a whole view of network, the resources, as well the attributes, constraints. So that's one use case. The other one is, you probably want to get notifications of the change of around in the network. That's the second one. The third one is, you may want to twist or change some of the attributes pertaining to the optical transport network. So you can also use this data model to do that. And next slide, please. Okay. Yeah. Another question I have in my mind is where to post the draft. Because I do see people coming here, and I want to thank them because I know for I2RS, I didn't actually involve initially, but I asked myself two questions. First is, a node talking GMPL's routing system or not? My answer is yes. Another one is, do the work fit in the I2RS scope? Because I think for the use case I just presented, they actually, you can say it's an I2RS client. So I post the draft here. As if you read the Young code or the tree, you see it's actually a standalone module, but that's not intent. So we will get aligned with the two drafts. First one is the network model, the other one is TE. So we need to figure out how I can augment it from there. But when I tried, I have some detailed issues, like they have some features which I don't see how I can augment or how I can do the link between them. So, but I will do that in the next step. The other one is I would really welcome overview of the draft, and also if you're interested in the work, please contact me. Any comments?
Hi, Lou Berger. So I think you're right about the details. They are important. The devil's always in the details, right? So if we go back a couple of slides. So looking at, well, we can look here. Or this is great. I have a hard time seeing what is L1 specific as opposed to generic TE. So I had a really hard time looking, when I look at the details, to see if there's anything different there. And I was actually happy to hear that you said that you looked and you saw some issues.
Yes.
And it would be, I think, really good to bring those issues into the discussion on that topology model. Because I think what you have here is very close. I don't know if it's 90, 100, 80, whatever % aligned with what's being done there, but it's really, really close.
I agree.
Now,
And definitely it's not 100%. I'm for sure.
so it'd be really good to bring that up in the context.
Yeah.
That document that Shufang was the lead author, and so it has his name on it. I expect to soon be a TEAS working group document. And it'd be really good to make sure it doesn't have holes. So if you see a hole, that's great. The other thing is down the line, we are doing generic topology right now in TEAS. The expectation is there will be some specifics to specific data plane technologies, like you mentioned, I think OTN. We would expect that to be done in CCAMP, or if it's MPLS, in MPLS, even if it isn't using GMPLS. So just because it doesn't use, you're not worrying about GMPLS, let's say you're using an orchestration, some centralized orchestration, that still can go to those working groups.
Yeah, completely agree, yeah.
And the thing that also I hope will happen is, if we just simply need to augment, what's the value add for I2RS at this point? Is what are we doing that's dynamic, state, and unique? So that's the other thing that Sean brought up.
I'm not sure I heard anything in this discussion that has that
Yes.
belongs in I2RS.
Yes.
If there is, that's cool. You know.
Well, we'll figure it out, but that's
Yeah.
that's been our question. That's been our question that we discussed, but we decided to follow the generic model that Alex provided and see what happened when we compared the two.
But if we look at the details, everything.
I don't see anything. So.
Yeah, well, more than that, it's an augmentation on top of the TE work.
Right, and that's what it should be, an augmentation on top of the TE work.
Great.
Thank you. And UT from Fusu, and if this document and the focusing on the layer 1 technology specific, as you said, like SH, OTN, and this document should also consider of the ITUT D.774 or D.874.1, and that describes the information model for these technologies. Yeah, this document is really good, but still very, very generic description as on this slide. Thank you.
Thank you for the comment.
Thank you very much. Any more questions? Our next is layer 2 then.
Morning, everyone. This is Jie from Huawei, and I'm going to talk about this layer 2 topology data model. That's lovely. Okay, so we can see the requirements of collecting network information under the layer 3 is specified in the topology requirement and also topology use case drafts. And the layer 2 topology model, the relationship between the layer 2 topology model and the generic topology model is also described in the network topology draft. So this is details about this layer 2 topology model. Okay, this slide shows the relationship between this layer 2 model and the generic network and the network topology model. Basically, we build this model with some augmentations to the generic net model and the generic network topology model defined in network topology draft, including the layer 2 network type and also layer 2 network specific attributes and layer 2 node specific attributes and layer 2 link specific attributes. Okay, next slide. We submitted the 0.0 version in last year, and also this draft was presented in the I2RS interim meetings. After that, we received a lot of good comments and suggestions. So this is update version 0.1. In this update, what we did in this update is we make it align with the updated generic network and network topology models. And also, we draw a line between the topology-specific information and the inventory information. Now the inventory model is in a separate draft. Another thing we did in this version is we open a mechanism to incorporate different layer 2 capabilities and parameters, including the VLANs and QNQ, PBB, Trio, VPRS, and the VXLAN. Next slide. This slide shows some details about how to incorporate different layer 2 technologies into this layer 2 model. we can see that for the layer 2 network, we can have different encapsulation types, like VXLAN, VPRS, VLAN, QinQ, Trio. All these different layer 2 encapsulations may be used to build one layer 2 topology. As shown in this below diagram, we can see that in the access you may use VLAN for the layer 2 connectivity, but in the middle you can use other different encapsulations, but they can build a whole layer 2 topology. So the mechanism we choose in the current version is to describe the encapsulation type as an attribute of the layer 2 termination points. Okay, next slide. This is a young tree about the layer 2 topology model. We can see that this is basically to augment the network and the network topology models with specific attributes. And during the discussion in the interim meeting, we also received a question about how to represent the tunnels in the layer 2 topology model. And after some discussion internally, we think that we may treat the tunnels as the supporting links and supporting termination points in this layer 2 topology model. Okay, next slide. Here is the next steps for this draft. So the plan is to revise this model and the draft based on the feedbacks received in this meeting, and we would like to encourage people to join this work on this layer 2 topology. Okay, Thomas?
Yeah, I think this is again general Himanshu Shah, general comment which Lou just said before, which applies to layer 1, layer 2. I think all of this work is happening in parallel with the other group. I think we really will have to be very careful, and as an I2RS working group chairs, you will have to police that not two parallel work conflicting happening in two different working groups. This should really be augmented from the other working group work.
That's
Unless
right.
there is something specific of I2RS related.
Again, I agree. Our goal in I2RS is to be the dynamic augment on top. We've started these models. If you have a specific place you feel this model should plug into, I'd like to know where you think the generic topology for layer 2. It didn't seem to be as close with T's as layer 1.
No, we are planning to cover the same thing in L2VPN service model.
I'm sorry.
L2VPN. So L2VPN is going to look into all of this. This is attachment circuit related stuff, right? So it's part of the layer 2 services and all that. So all of this pseudo wires and the attachment circuits and the layer 2 services over MPLS and all of those will be covered in L2VPN.
Yes, but this is a summary draft, just as Alex put, that would summarize the combined topologies. So this is one where you inherit it, just like you would inherit OSPF into this, into the layer 3, you would inherit this is a general topology. So you could add, a person could have layer L2VPN and some other connectivity feeding into a generic topology. Remember how Alex had OSPF and ISIs feeding into generic topologies?
Yeah.
That's the intent here. This is just a summarization of all the topologies in a dynamic place where people might also pull up the other models.
Right, but so these, some of the stuff that are being shown here,
Yes.
I mean, that would be inherited from the L2VPN.
Yes, that's
model,
correct.
right?
That's right.
So again, I think
Absolutely.
we're talking about L1 and L2 and all that.
Absolutely.
Those shouldn't be actually going through the I2RS, right? Unless there is a special twist to I2RS specific.
This model is a summary of the other models, just as Alex put it. We would also assume that the other models would be done, the L2VPN and other models would be done within those working groups. And I2RS is providing the dynamic common state for a common model. We have a very small box we work in.
Okay.
And yes, One of the challenges for I2S is we have to stay connected to all the other working groups.
Exactly.
And it's a very good point, Homijo. I belabored it because it's a question the design team has debated, it's something we've worked with the ADs, and it's something we're going to continue to need to work. I hope you don't mind me giving you a long answer, but it's one I've been asked several times. Great question.
Okay, thank you.
Do you want to jump the line?
So yeah, I think actually if you have some specific topologies and so forth, I think we've actually I'd be very interested actually in having this exchange there, because then basically the goal would be clearly basically to have that tie into also the generic. So basically if you have some specific topologies and so forth, I would actually like to see how to align it and how to match it. Okay, thanks. Sorry for jumping.
Yeah, we just formed a layer 2 VPN design team. So we will, starting from a couple of weeks, we will have WebEx calls, and we would be doing this design for the L2 VPN. So
Good. Well,
I can
we'll
forward the invite there.
Perhaps G can listen in on that, and we can help.
Sure, yeah. I mean, more the merrier. It's going to be partitioned into a lot of different things. It's a huge thing, so yeah.
Yeah, we can work together on this. Layer 2 VPN actually in this topology, I can treat it as a connectivity, right? I don't reflect details of the layer 2 VPN in this topology models. So maybe there's some connection or relation between the two models, and we can coordinate that definitely.
Ganesh Kini from Ericsson. Can we go back to slide 5, please? Okay.
This is the one you wanted?
Yes.
Or the one above?
No, actually this one. Yeah,
Okay, that's one.
Right. So I'm trying to understand what is the topology model trying to achieve, because in this diagram, the same diagram that you have, what all elements would be there in the topology? Would they be the nodes in the middle that are realizing the service, or is it the service as in a list of the endpoints of the service? It's not clear to me. What would be there in the L2 topology model for this specific example?
I'll try to help. Do you want my help, G?
Yeah, I can explain first. For the layer 2 topology, we just want to explain the layer 2 connectivity in the network. This connectivity can use different specific technologies on each segment, actually. But they can be viewed as a whole topology in the layer 2 layer, right?
Right.
This is just a perspective on this.
So in this diagram, if you have a L2 service, then I guess the three end nodes would be a part of the service, right? There would be attachment circuits coming into those three nodes, whereas the middle node would not be there in that topology. But if I'm talking about the topology that is realizing the L2 service, including the code, then all four nodes would be in the topology. So it's not clear to me whether the topology model would have 3 nodes or would it have 4 nodes.
In the middle, there are layer 2 services. In the middle of this diagram, there are layer 2 services. And in my layer 2 services also.
I'm sorry to interrupt you, but would you hold the mic or put it close to you?
Okay. So in my view, this layer 2 services also work together to build a layer 2 topology. In this data model, we only treat all these layer 2 services as a layer 2 connection. So we just want to describe the connectivity in this layer. I think any layer 2 services can build this part of this topology.
I'm not sure
for the details of this service, I think they can be technology-specific models. But this one just describes the connectivity together to build a topology.
Okay, so would it have 3 or 4? Would it have 3 nodes or 4 nodes in the L2 topology for this?
3 nodes or 4 nodes?
Right, you have those 3 nodes at which the attachment circuit is coming in.
This is just an example. You mean the node in the middle?
Would the node in the middle be in the L2 topology or not?
Yeah, it depends which kind of encapsulation you use.
any encapsulation?
Some kind of technology here, like a overlay, like overlay technology, but some like Trio, like PBB, they are not overlay. They are still hub by hub.
So the node in the middle, it doesn't have any attachment circuits coming to it, correct? For the L2 service that is being delivered?
I think we can discuss after the meeting.
Okay.
Are you monitoring which mic?
No, I didn't monitor that one. Were you next?
I was before him, but it's okay. Please go ahead.
It doesn't matter. Please go ahead and announce your name.
Okay, sure. I'm Amatoy with Comcast. I think it's a good start. My point here is when you say networks start with the interfaces, endpoints, and things like that. And that is being worked very well in the Metro Ethernet forum, at least for the layer 2 Metro E services, and of course for the networks. I recommend you to look into that and take those work which is done there and incorporate here. That will be very useful to everybody. So if you need to have more information, certainly you can get in touch with me as well. Thank you.
Okay, now, Don.
Don Fedek. I'd like to see between the models the same terminology used. So here we have tunnels and encapsulations, and in the layer 3 model we had overlay and underlay. And as far as I'm concerned, they're the same unless I'm wrong, but I'd like to see why the terminology used for the same type of mechanism.
They should be consistent.
Yes.
Point well noted.
Thank you.
Okay.
Dan Bogdanovich. I have a question on this. I'm trying to find out the use for all the topology models that are presented, and seeing from the I2RS perspective. Why do we need all these models, and couldn't we actually reduce the number of models and try to put them together in a more meaningful way? Because covering all those models, I'm not sure about the value of each one.
Okay. A good point would be to go back to our use case requirements and tag in where the specific uses were. Is that what I'm hearing?
Yes.
Okay. So each model, that would be a good thing to go back through the use case requirements and find it. By the way, thank you for all the comments. This is our first blush, and it really helps us to discuss that. We have one more, unless there are questions for G. And I expected this one to have more questions. Michael, are you here? Okay. I will help Michael out a little bit as I think of all the topologies. If you found concerns with them, I think the design team felt most concerned with our service models. We've thrown a service forwarding as an example, but I think we really need more discussion. So as Michael goes forward, you may get answers like, does this make sense, and are we really doing something? Before we go, let me get one more statement, Joel. We did this as an example of a general service topology. We don't know if there's a general service topology. We just started in this direction.
But Joel Halpern, I have a general question here, not about is there a general service topology. I don't think there is such a beast, but it doesn't matter. There is already a Yang model for service function forwarders and the way they're going to be used for service chains and service function paths, and that's being worked by the service function chaining working group. And I'm really trying to get my head around what's the relationship between this model and that model.
Good question. We did actually look, since I'm on this one, I'm helping. I'm I'm helping with this one. The authors did go back and look at each piece of the Penno draft and the OAM draft, Joel. And the information required by the use cases wasn't really in the Penno draft. If you have feedback how we should either contribute it back, or if this is an independent topology from people working on service function forwarder, we'd appreciate it. Now, Michael, on to you.
Okay, thank you. Hello, everyone. My name is Michael, work for Huawei, and today I want to talk about the SF topology YARN module. Okay, the first page, I want to talk about the relationship of the SF topology and other topology modules. And we see the layer 2 and the layer TE topology module and our SF topology module based on the Alexander's generic topology module, and this figure shows the relationship of our SF topology module. It's based on one of several topology modules, and the SF topology module is kind of service topology. Okay, at that side, SF topology is built on the top of one or more underlayer network, and it's based on the generic module. But which multiple SF topologies can build on the same underlayer network, and each tenant can only see his service topology. But all this tenant service topology may map into the same layer 3 network topology. Okay, another question is where we can get the service topology module, where we can get the service topology information. Fortunately, the I2RS agent can set static configuration, and service topology information can also gather from another resource. For example, IGPs and another data can provide the routing system topology information, and the other system topology information may be downloaded by the I2RS agent. Okay, we'll talk about the design of service topology, SF topology YARN module. We have to understand what's the node type, which is a classifier node, SF node, or SSF node, and we have two corresponding extension for classifier extension, SF node extension, and SFF extension. Okay, this shows the tree structure of SF's YARN modules. We have augmented the Alexander's basic modules for node list, and have a node type to indicate which this node is classifier node, SF node, or SFF node. So we have three node extension, each classifier extension, SFF node extension, and SF node extension. Okay. Question?
Joel Halpern again. Can you back up a little bit? I'm not, just next page. I'm not understanding two different aspects of this model. One, we don't want to make a catalog of all the kinds of SFs because we can't. There's myriad kinds of SFs, so I'm not sure I understand what would go in SF type. Now, if SF type were simply a uint32 that went and pointed off in some registry, okay. But then I get really confused when I see a field under there that is firewall that is a uint32. Like, are there firewall types or something? I don't understand what you're representing here.
So this first one, some of my comments toward the author were, let's see what we can find inside of the Penno draft to reference. These types should reference the original panel draft types.
I can't even figure out what you'd be doing with this structure, I'm sorry.
As far as the node, are you asking with the SF node?
Types, and I can understand wanting some abstract field that says, here's a type identifier, it's opaque, whether it's a string or a number, but then it's broken down and I start getting very
Good correction made. I think the next version should have that. Agreed, Joel.
On that. Should not list all the service, sorry, this is Linda. I actually probably comment this week. We should not list literally the type of the service functions, but we can list the capability, whether you support the
Linda,
header or something.
face the microphone.
Okay, so
Thanks.
basically list what kind of header you support, whether some capabilities maybe can be listed, but not the type. That's,
Good point. As one of the authors, you and Michael, that would be good. More comments?
Diego Lopez, no, it's in the same direction as what Joel was mentioning. I found when reading this, I found really concerning this classification. And even the capabilities, as Linda says, it's something that we should be extremely careful about this if we don't allow a mechanism for, I don't know, for some kind of free format in the case that any other please specify as in many forms, because otherwise pretending that we are in the position of making a complete list of all functions impossible, all capabilities really difficult is going too far and will take, well, you know.
Okay, so I'll ask one question in response, Diego, that would help this working group chair. In the original, this one, and is targeted off of some original use cases that were submitted to I2RS. Is there a way we can get some of those use cases reviewed by SFC to make sure that we're in good alignment? Because I'm sensing there's a whole lot of mystery between the original work we got 2 years ago and now.
I cannot speak for SFC officially, but
Yeah.
I think, if you ask me, I think it would be a clever move, yes.
Okay,
definitely.
so I think we should go back to the actual requirements, clean them out. We've asked for calls on the requirements of the use case draft, but that's a lengthy draft. Go ahead.
Andrew Dolgan and Alcatalucen. I kind of second this. You should probably take this to SFC because let us discuss this a little bit more there. And you're connecting too much network back when we try
Okay.
to separate this from the network. And you're
Thank-
putting too many details in.
Okay, so our next step from the service area is to go back to each service area, check our requirements, and go forward. Good, thank you. Thank you, Michael. By the way, we really appreciate all this feedback. I think taking some of clue, we just started off in a direction and hoped we could begin it. If we have to stop and go another direction, the design teams are very happy to do that. We just tried to start to make work happen. Now I'm going to talk about a new portion of the charter. The charter is online, and I think Jeff has indicated a key part of the topology charter in that we are really chartered to do read topologies. In the case, our use case indicate that people wanted to be able to read various layers of topology in some sort of connectivity link. The second thing that was added to our charter is this filter-based rib. The filter-based ribs are ribs just like our rib info, which are actually filters. And I'm going to go on to describe some of the original discussions on that. I love this. But again, we welcome design people who want to talk about this. design teams, anyone on the design team, anyone in the discussions? Shall I do this one? Me or you? Okay. Okay, you want to do there's a PowerPoint if that's easier. Okay, again, am I hearable back there? Okay. Again, we are trying to start the direction with protocol-independent ribs, filter ribs, and protocol topology. Now, one thing that you get into a challenge on when you start talking about a generic filter rib, and that filter rib is really a match of some sort of thing, an ordered match, and then, Joel, I'll go on to it in just a minute, just give me the architecture. We will begin to discuss matches at layer 1, layer 2, layer 3, and then service, somewhat to follow our generic topology. We do not know if this is the right way. We've just started out that direction, and we would love feedback. Go ahead, Jeff. So what is a filter-based rib? A filter-based rib is an ordered list of rules. I've given an example here with Rule 10, and then within it, the initial concept is there might be a priority, a group of things at priority 1 and priority 2. That way you have a list of matches. So you might have rule order 10 and then priorities within it, rule order 30s with just one, and rule order 100. So that's our definition of rule ordering. Okay, this is the initial input. I hope we've done a good job as an initial kickoff team. Go ahead, Jeff. There is a policy draft we refer to as the BNP policy match, but please note the routing working group has got a lot of really good policy work, and this policy match rule form was just one we started with. And it again is match. Now, the thing we knew is there'd be ACLs, so this actually has a type before it actually has the type of match. So if you wanted to have a rule match, it'll say rule match ACL and then take an augment out of the ACL. If you have a generic type, then it has the form match. This could be replaced by a couple of the proposals that were given in the routing working group. That's fine with I2RS. Go ahead. This is a simple fib model, instance name, router ID, interface, rib name, status, and then the ordered filters. This should look very similar to the other work. Go ahead. What's next? We need a lot of help. This is a beginning draft that says how you might do generic filter forms. Do we need to have layer 1, layer 2? Our goal is not to do any work. I know that sounds very funny, but we would rather, as him and Shu said, pick up and say, we're just the dynamic piece. It's already done over here, here's the dynamic piece. The fact we've started with something does not mean we need to stay with it, but it is a beginning of an ordered list. I have not seen an ordered list, match list, except in the policy for routing working group. So if there's something else that's already doing that, Joel, except for there are some in the SFF, in the Peno draft, there are some matches. But that one seemed to be too specific for that. Go ahead, Dan.
In the routing working group, there was a call for a route filter design team. There was on a mailing list, I remember that.
Yes.
Yeah.
Yeah. And again, this is a case where I2RS will follow the base configuration model. You know, it's like I2RS comes at the end of the pack. However, we're not sort of sitting there waiting for everyone else. We're launching out into a direction. Okay? I have one other example that we put into the service model, but I don't know if we won't just have more confusion, so I'll take a pause here. I asked Linda to try to help me with something that might be service level here, but I'm not sure that's really going to be a good fit based on our other work. So I'll take questions on filter rib right now, and then I think we might take the opportunity to close early. I'm sure that everyone could use an extra 45 minutes.
I have a question here on the filter rib, because yours here showing simplified filters, but it would be interesting to see if you would support chaining of filters. So essentially that a filter, a filter calls a filter. Or that you can chain terms within the filter, or you can chain filters together.
Good question. Haven't decided.
Actually, I just want to clarify that service chain, I2RS interface, it's addressed that. Chain of
Yes,
filters.
yes, that does.
So if you can show
Yeah.
that one picture, then that'll be good. Like just give some feedback.
Jeff, if you go to the next slide, I'll pick up the right slide from there. And by the way, service function forwarding, it should be the draft unbar. And then we have one more presentation. I forgot. Ran, are you here? Ran Chen? He was going to do an identity management. I announced a lightning round in case stuff, but go down. I'll see if I can pick out. Yeah, it's, go one more down.
Yeah, this page, just show that.
Microphone, please.
I'm not sure this shows it really well, Linda.
Okay, this is really to show that in lots of implementation of service chain, people have, over the past 2 years, using OpenFlow to control the traffic steering. Here we're using I2RS to control the service steering, traffic steering to achieve the service chain. Next one. Next one. Yeah,
Yeah,
just
that's
this
it.
page. Yeah. So this is just to show that the slight difference, addition, augment to the rate model to address things common that for the service chaining, the traffic is not just coming in and go out. Actually, it goes through a chain. Like for specific matching condition, you have to go through a list of addresses before you go out. So that's just to show the chain of
Right, but that
filtering.
doesn't show the chaining that's fine. Thank you. Dan, I think you're right. We need to think about chaining. Ran Chen, are you here in the room? Okay. There is an identity management slide set on the presentation web, but I think our speaker's not here. Yeah, I don't know the last speaker. If you're doing the identity management, who asked it? Ran? Okay. Then I think we're done. Is there any other questions for R2S?
So one thing I will actually interject, if you have a draft in I2RS that's been presented here, please make sure that it is on the RTG Yang coordination page. A significant number of the drafts that were presented here today have overlap in more than one group or more than one technology. It is your job as one of the participants to seek out related work, coordinate with people, make sure it's done in the right area, and make sure any common components in the IETF get done in the right places. And combine.
And compliance, yes. Thank you very much. We'll see you in Prague. Did I miss the guy? I've not had a speaker just in chat.
They were supposed to be lightning round.
Oh, lots of work yet to do on the clock. Good stuff.
Oh, yes.
That's the fun thing, I think, as we're working on these.
That's it, I don't need to save anything, right? You see that everything, right? Just save. No, I don't know how to save it. I have been typing it and... That's fine, but it's... Okay, lots of work, lots of good stuff, lots of good comments.
Right after this.
The person. Yes.
Oh, actually, which is most important.
Good.